Hello, my name is Daniel, and today we will be going through the AMC 12B from the year 2002, so let's get started. First problem, the arithmetic mean of the 9 numbers in the set this one is a 9-digit number m, all of whose digits are distinct. The number m does not contain the digit in one of these 5, right? So if we try to get the mean of these, then it's just 9 plus 99 plus 999 plus all the way to 999999999 all divided by 9, right? And so all the 9's cancel, so this is equal to 1 plus 1 1 plus 1 1 1 plus all the way to 9 ones 1 1 1 1 1 1 1 1 1, right? So this is going to be all equal to 1 2 3 4 5 6 7 8 9, and the only digit that we have missing here is 0, so the answer is 8. Number 2, what is the value of this thing when x is equal to 4? Okay, so since these two are the same, then we can just make those two be together. So it's 3x minus 2, 3x minus 2 times 4x plus 1 minus 4x, which is 1. And so we have minus 1 after that, so x equals 4. Then that would give us 10 plus 1. This is 10 plus 1, so this equals 11. The answer is D. Number 3, for how many positive integer n is this a prime number? Okay, so this can be factored into n minus 2, and n minus 1. And for this to be a prime number, then one of the factors has to be 1, because a prime number's only factors are 1 and itself, right? And so we can have two choices. This can be 1 or this can be 1, right? So let's say that this one is 1. Let's say n is equal to 1. N is equal to 2 to make this one 1. That will make this whole thing 0, right? And then if this is 1, n is equal to 3, so that will make this is 1, and this is 2, right? So that will make it 2. And 0 is not a prime number, so this is out. But 2 is a prime number, so that is okay. And so we only have one positive integer n, which is 3. So the answer is B. Number 4, let n be a positive integer such that this is an integer which of the following statements is not true. Okay, so first let's try these 3. So if we just compute them, it's just all over 2 times 3 times 7, so it's all over 42. And then we have 7 times 3, 21, plus 2 times 7, 14, plus 2 times 3, 6, right? So this is 41 over 42. And so if we want to add 1 over n to be an integer, that means n is going to be equal to 42. So the answer is E, because 42 is not greater than 84. The answer is E. Number 5, let V, W, X, Y, and Z be the degree measures of the 5 angles of a pentagon, and suppose that this holds true, and V, W, X, Y, and Z form an arithmetic sequence. Find the value of X. Okay, so since they form an arithmetic sequence, and that's their order, then V, W, X, Y, Z would be something like X minus 2A, X minus A, X plus A, and X plus 2A, right? And so their sum is 5x, but then that's the sum of the interior angles of a pentagon, which is just 540 degrees, right? So x is equal to 540 divided by 5, and so that is equal to 108 degrees. So the answer is D. Number 6, suppose that a and b are non-zero real numbers and that equation this has solutions a and b. Then the pair a comma b is. Okay, so since a and b are the solutions to these things, and we know that b is the multiple of the roots, so b is a times b, and negative a is the sum of the roots, so it's a plus b, right? And so from this we can get that a equals 1, and since a equals 1, then we can get that b equals negative 2, so we have 1 comma negative 2. That's the answer. It's C. Number 7, the product of 3 consecutive positive integers is 8 times their sum. What is the sum of their squares? Okay, so we have 3 consecutive positive integers, so that means we have a minus 1, a, and a plus 1, right? And their product, so these timed together, is 8 times their sum, 8 times 3a. So this is 24a, right? And so 24a. And so if we cancel a from both sides, then that gives us a minus 1. Yeah, so that gives us a minus 1 times a plus 1 equals 24. And 24 equals 4 times 6. So this is 4 and this is 6. So that means that the three numbers are 4, 6, and the one between them. So 4, 5, and 6. But we want the sum of their squares, so 4 squared, so 4 squared plus 5 squared plus 6 squared equals 16 plus 25 plus 36. And that is equal to 77. So the answer is 77. It's B. Number 8, suppose July of year n has 5 Mondays. Which of the following must occur 5 times in August of year n, and both months have 31 days? Okay, so let's just make a kind of calendar. We have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, right? Okay, so here, since July has 5 Mondays and both months have 31 days, so 4 full weeks, and we have 3 extra days, right? But then since it has 5 Mondays, that means it must contain at least 1 Monday, and so we can make the 2 days either Saturday and Sunday, or Sunday and Tuesday, or Tuesday and Wednesday, right? But in any case, if we, so the green is July, and if we say that the red is, say that the orange is August, right? If these 3 days are Monday, Tuesday, and Wednesday, then August will start from Thursday. And if July ends on a Tuesday and has like that, then August will start from Wednesday. And lastly, if July starts on Saturday and ends with a Monday, then that means that August will start on a Tuesday. So that means that August first week has Thursday to Saturday, and this is 100%, right? Because in any case, Thursday to Saturday will be in the first week of August, right? And the next, August also has 31 days. If we say that August has 4 weeks like that, so we have the first week, and then we have the second, third, and fourth week, and then so our gaps, let's say the gaps are bright blue, so we can have a gap of 1 day, or we can have a gap of 2 days, or we can have a gap of 3 days, right? And so accordingly, we will have days will be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or they will go, this is that's for this case, and for that case, we will have 5 days at the last week, and for this case, we will have 4 days at the last week, right? And so if we look at the last week of August, last week of August, this has Monday to Thursday will always be there, 100%, right? Because Monday to Thursday, that's always there in the last week of August, right? And if you see, the only day that overlaps is Thursday, right? So that means Thursday must occur 5 times in August of year end. So the answer is Thursday. It's D. Number 9, if A, B, C, D are positive real numbers such that A, B, C, D form an increasing arithmetic sequence and A, B, D form a geometric sequence, then A over D is. Okay, so A is the first number, B is the second number, C is the third number, D is the fourth number, right? So A, B, C, D, that will be something like 2, 4, 6, 8, like that, right? And A, B, D, this should form a geometric sequence, right? And then if you see this particular sequence, then you actually see that it does form a geometric sequence, right? And the same is true of like A, B, C, D, 1, 2, 3, 4. This is an arithmetic sequence. But then 1, 2, 4, this is a geometric sequence, right? So this holds true. And so A over D, this is A, and this is D. So A over D, this is equal to 1 over 4. The answer is C. Number 10, how many different integers can be expressed as the sum of 3 distinct members of the set this? If you see here, all of the numbers here, they are multiples of 3, and then plus 1, right? So that means that the sum of 3 members from the set is going to be always a multiple of 3, right? And so if we look at the minimum value that this can make, then the minimum is 147, so that gives 12, and the maximum is 13, 16, 19, so that gives 48. And so the total number of possibilities equals 48 minus 12 over 3, right? Because they are all multiples of 3, and then we have to add 1 because both 12 and 48 are possible. So this is 36 over 3 plus 1. This is 12 plus 1, which equals 13. So the answer is 13. It's A. Number 11. The positive integers a, b, a minus b, and a plus b are all prime numbers. The sum of these 4 primes is even, divisible by 3, divisible by 5, divisible by 7, or prime. right? Okay, so first of all, since a minus b and a plus b, they are both prime, that means b must be 2, right? So b must be even, actually, but then since b is also a prime number, that means b must be 2, right? So we have a 2, a minus 2, and a plus 2, they should be all prime numbers, right? And then if we look at a equals 5, then that is actually the case, right? So that would be 5, 2, 5 minus 2, which is 3, and 5 plus 2, which is 7. And so the sum of these 4 primes, this is 17, and 17 is prime. The answer is E. Number 12, for how many integers is this the square of an integer? Okay, so let's say this integer is x. So, no, let's say it's k. So it's n over 20 minus n. This equals k squared, right? Let's put this here. And so that's k squared. And so if you write this in terms of n, that means n equals 20 minus n times k squared. So n equals 20k squared minus nk squared. So 1 plus k squared times n equals 20k squared. So n equals 20k squared over 1 plus k squared, right? And so the possible values of 1 plus k squared is these are all factors of 20, right? And so 1 plus k squared, this can be 1, or this can be 2, or this can be what can it be? This can be 5, or this can be 10, etc., right? And then for these, those are the only factors of 20 that will make 1 plus k squared, that will make k an integer. So these will have k equaling 0, 1, 2, and 3, right? So we have 4 values in total. The answer is 4. It's D. Number 13, the sum of 18 consecutive positive integers is a perfect square. The smallest possible value of this sum is. Okay, so since we need 18 consecutive positive integers, then let's just say that we have an a. We will go from here, and then we will add a plus 1, a plus 2, yeah, so a plus 2, a plus 3, all the way to a plus 9, and then go here backwards. So a minus 1, and then plus a minus 2, all the way to a minus 8, right? Because that's the only way that this will be 18 numbers, right? So the sum of these 18 numbers is going to be 18a plus 9, right? Because this is going to, yeah, so because a plus 8 and a plus 9 and a plus 9, this much is going to just be 17a. So this added equals 18a plus 9, but then this is a perfect square, so this is 9 times 2a plus 1, right? And we want the smallest value of that. But then look, since a minus 8 should be a positive integer, that means a is greater than or equal to 9, right? By this, since the whole thing is prime, and since the whole thing is a perfect square and 9 is also a perfect square, that means 2a plus 1 must also be a perfect square. So 2a plus 1 equals perfect square, right? But then since this is an odd number, this means this is a perfect square, but it's odd. And so this should be 1 squared, 3 squared, which is 9, 5 squared, 25, and so on. But then a has to be greater than or equal to 9. So the least value of 2a plus 1 that is also in accordance with this clause, that is just 25, right? So 2a plus 1 equals 25. So 25 times 9, this equals to 25. The answer is B. Number 14, 4 distinct circles are drawn on a plane. What is the maximum number of points where at least 2 of the circles intersect? We want the maximum number of points, so we can just draw them like this, this, and this. So that will be the maximum number of points. So if we count them, they will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 points. The answer is D. Number 15, how many 4-digit numbers n have the property that the 3-digit number obtained by removing the leftmost digit is 1/9 of n? Okay, so let's say that the 4-digit number is a, b, c, d, this being 1000a plus 100b plus 10c plus d. And so that means 1000a plus 100b plus 10c plus d equals 9 times 100b plus 10c plus d, right? So if this goes over there, then that would mean that 1000a would be equal to 8 times 100b plus 10c plus d. Let's just write that as BCD, right? And so since 1000 is divisible by 8, that means 125a equals BCD, right? And so a can be all the values from 1 to 7, and not 8, because if a is 8, if a is 8, if a is 8, b, c, d would have to be 1000, and then that is not possible, right? So that's why a cannot be 8. So it's 8. So a is all the numbers from 1 to 7. This is 7 numbers. So the answer is 7. It's D. Number 16. Juan rolls a fair regular octahedral die marked with the numbers 1 through 8. Then Amal rolls a fair six-sided die. What is the probability that the product of the two rolls is a multiple of 3? Okay, so the probability that the product is a multiple of 3, that is satisfied when just even one of those two dies gets a multiple of 3, right? So the way to get this probability is 1 minus the probability that the octahedral die didn't get a multiple of 3, so it's not a multiple of 3, and the regular six-sided die is not a multiple of 3, right? And so for the 8-sided die to not be a multiple of 3, it's numbers from 1 to 8, but then we don't have 2 and we don't have 6, right? So that's 6 over, so this is 6 over 8, which is just 3 over 4, right? And this is, we just have to take away 2 and 6 from 6 numbers, so that's 4 over 6, and so this is equal to 2 over 3, right? And so this is equal to 1 minus 3 over 4 times 2 over 3. This is 1 minus 1 half. This is equal to 1 over 2. So this is the answer. It's C. Number 17. Andy's lawn has twice as much area as Beth's lawn, and 3 times as much area as Carlos's lawn. Carlos's lawnmower cuts half as fast as Beth's mower and 1/3 as fast as Andy's mower. If they all start to mow their lawns at the same time, who will finish first? Okay, so let's compare Andy, Beth, and Carlos, right? First, let's compare by area of their lawn, right? So Andy has twice as much as Beth and 3 times as much as Carlos. So if Andy has 6 acres, then Beth would have 3 acres and Carlos would have 2, right? But then now let's compare by speed of the mowers. Speed of their mowers. Carlos is half as fast as Beth and 1/3 as fast as Andy's. So if Carlos' lawnmower cuts 2 acres per minute, then Beth would go 4 acres per minute, and Andy would go 6 acres per minute, right? So 6 acres per minute, that is really fast. 4 acres per minute, that is also really fast. And 2 acres per minute, that is also really, really fast. And so here Andy would take 1 minute, and Beth would take 3 over 4 minute, and Carlos would take 1 minute, right? So who will finish first? That is 3 over 4 minutes. That is Beth. The answer is B. Number 18. A point P is randomly selected from the rectangular region with vertices 0, 0, 2, 0, 2, 1, 0, 1. What is the probability that P is closer to the origin than it is to the point 3, 1? Okay, so let's draw just a coordinate plane like this. So we have 0, 0, and we have 2, 0, like that. So we have 2, 0, and we have 2, 1. So we will have 1 like that, and we will have 2, 1 like that, and 0, 1 like that, right? And then P is closer to the origin than it is to the point 3, 1. Okay, so where's 3, 1? This is 3, then 3, 1 will be this one. That will be this one, right? And so it is selected from this region, and P has to be closer to the origin than 3, 1. Sorry, that's not 3, 1, that's 3, 0. So 3, 1, that should be right here, right? And let's connect the origin to point 3, 1. So if it's like that, then we should have like a line like that. That's like that. And so this would go through this point, which is 1, 2, which is 1, 2. And it will also go through this point, which is 2, -1, right? Because this is slope is 1 over 3, so this slope is -3, right? And so the probability that P is closer to the origin than it is to point 3, 1, that's just this area over the area of the whole rectangle, right? And so if we get that, first of all, we can divide this like that, and then we will see that this, so we can see that this area is equal to this area, right? Because the blue line cuts it exactly in half. So if we make like one more blue line like this, right? Then that means we have three of these pieces out of a total 4, right? And their areas are all equal, so it's 3 over 4. The answer is C. Number 19, if A, B, and C are positive real numbers such that A times B plus C equals 152, B times C plus C equals 162, and C times A plus B is 170, then A, B, C is. Okay, so here, let's say A plus B plus C, this is equal to K, right? Then A times K minus A, this will equal 152, which is 8 times 19. And the next is B times C plus A, so it's B times K minus B. And so this is 162, this is 9 times 18, right? And then C times A plus B, this is C times K minus C. This is 170, and this is obviously 10 times 17. 10 times 17. So these values are possible A K minus A, B K minus B, and C K minus C values. And then if you add them all up, the sum is all 27, right? Because A plus 19 is 27, this is 27, this is 27 added together, right? And so this means 27 equals K, right? And so A equals 8, B equals 9, and C equals 10. That will make the sum also 27, right? So we want A times B times C. So A, B, C, this is 8 times 9 times 10. This equals 720. So the answer is D. Number 20, let triangle XOY be a right angle triangle with angle XOY equals 90 degrees. Let M and N be the midpoints of legs OX and OY respectively, given that XN equals 19 and YM equals 22. Find XY. Okay, so let's first draw a diagram of this thing here. That would be like that, right? And so we will have angle XOY equals 90, so this is 90 degrees, right? And then these are the midpoints, right? So this and this would be equal, and this length would also be equal, right? So let's call XM and MO, let's call these A, and let's call these B. And XN is 19, so this is 19, and YM equals 22. Okay, so we can also get XN and YM by doing Pythagorean theorem with this right triangle and this right triangle, right? So if we do that and compare, then that gives us okay, so XN first, 19 squared, this equals 2A squared plus B squared, because it's this triangle, right? And so, and also for YM equals 22, 22 squared equals, because it's this right triangle, right? So it's A squared plus 2B squared, and if we add these up, then it becomes 5A squared plus B squared equals 19 squared plus 22 squared, which is 484 plus 361. This is 19 squared and this is 22 squared. This is equal to, that is equal to 845. So A squared plus B squared equals 845 divided by 5, which is 169, right? And now we want XY. For XY, we can just look at this full right triangle, right? So XY squared, let's just do XY equals, and then square root of 2A squared plus 2B squared. This is root 4 times A squared plus B squared. This is 2 root A squared plus B squared, right? So this is 2 root 169. This is 2 root and then 13 squared, which is 2 times 13. So this is 26. So 26 is the answer. It's B. Number 21, for all positive integers n less than 2002, let this be satisfied. Calculate this, right? But then we all know that 2002, this equals 11 times 13 times 14. And if you didn't know this fact, this comes up very often in like this year problems, because 2002 is the year and they like to make problems with the year in them. So it's always good to know the factorization of the year that you're taking the test, right? Okay, so 2002 is 11 times 13 times 14, right? But then it has to be less than 2002. That means the number of n's that is divisible by 13 and 14, this is going to be 11 times, so that's going to be 2002 divided by 13 times 14 and then minus 1, because 2002 itself cannot be in it. So that's just 11 minus 1, that's 10, right? That's 10 possible n's. For this thing, it's the same. There should be 13, but then 2002 is impossible, so that's 13 minus 1 equals 12 possible ends. For here, same thing, 14 minus 1 equals 13 possible ends, right? And then these values are 11, 13, and 14. So what we get is, because of the 0, then we don't need to care about what happens otherwise, right? And so if we just calculate everything, it's just 11 times 10 plus 13 times 12 plus 14 times 13, right? Because there are 10 occurrences of a n being 11, and there are 12 occurrences of a n being 13, and there are 13 occurrences of a n being 14, right? So if we just do these and add these up, this is 110 plus 13 times 12, that's 156, plus 14 times 13, which is 182. So this is equal to 448. So it's 448. The answer is A. Number 22, for all integers n greater than 1, define an as this thing. Let b equals a2 plus a3 plus a4 plus a5, and c equals a10 all the way to a14. Then we want what b minus c is, right? First of all, we know that an, this is log 2002, and because this is log n 2002, and then that's under 1, so we can change these two as we get rid of this, right? So an is log 2002n, and so then b minus c would equal a2 plus 3 plus 4 plus 5, so it's log 2002, and then 2 times 3 times 4 times 5, and then minus c, which is log 2002, and then 10 to 14, so that would be 10, 11, 12, 13, 14. So this is equal to log 2002, and it's going to be all 2, 3, 4, 5 over 10, 11, 12, 13, 14, right? And so it's going to be these two are going to cancel, and 3 and 4 are going to cancel. So this is log 2002, and then that to 1 over 11 times 13 times 14, which is 2002, as we saw. So this is 2002 to the negative first power. This is minus 1, right? Because this thing becomes 0, and this is all that's left. So it's minus 1. The answer is B. Problem number 23. In triangle ABC, we have AB equals 1 and AC equals 2. Side BC and the median from A to BC have the same length. What is BC? Okay, so first of all, let's draw this diagram out. So this would be what it looks like. AB equals 1, so this would be 1. AC equals 2, it's 2. Side BC, and so this side and this length has the same length. So let's say that since this is half-half, let's say it's A, and so this length would be 2A, right? And let's just call this point D, right? And so what is BC? And so we can use the cosine law for ABD, for ABD and ADC, right? And so if we use it on ABD, we will focus on this, so that length. So that means 1 squared is equal to a squared plus 2a squared minus 2 times a times 2a cosine ADB, right? And then if we use it on ADC, let's focus on this line, AC this time. So that would become on ADC, 2 squared is equal to a squared plus 2a squared minus 2 times a times 2a times cosine ADC, right? From both sides for ABD, cosine ADB, this is going to be equal to going to be equal to 1 minus 5a squared over 4a squared, right? And then for this one, cosine ADC is going to be 4 minus 5a squared over 4a squared, right? And so this is the cosine values for this angle and this angle, right? But then since they sum to 180 degrees, then we can see that cosine ADB should be equal to negative cosine ADC. And so cosine ADB, we will compare this one and this one, right? And so we can just cancel these out, or cancel these out from the first. And so that will just be equal to 1 minus 5a squared equals negative, and then this negative 4 minus 5a squared, 4 minus 5a squared, right? And so 1 minus 5a squared equals negative 4 plus 5a squared. 10a squared equals 5, so a squared equals 1/2. A equals root 2 over 2. So we want BC. BC is 2a, and that is equal to root 2. So the answer is root 2, it's C. Number 24, a convex quadrilateral ABCD with area 2002 contains a point P in its interior such that PA equals 24, PB is 32, PC is 28, PD is 45. So find the perimeter of ABCD. Right, okay, so our quadrilateral is, so it might be something like this, and it has a point P like that, and this A, B, C, D, let's say, then these points, so those lines would all be 24, 32, 28, and 45 for the perimeter of ABCD. First of all, let's try PA plus PC times PB plus PD, and then multiply by half, right? So if we do that, that's going to be 24 plus 28, which is 52, times PB plus PD, which is 77, and then times 1/2. So this is 52 times 77 times 1/2, which is 26 times 77, and that is equal to 2002, right? So that's equal to 2002, and so, but then it said that the area is 2002, which is the area, right? And so that must mean that PA plus PC and PB plus PD, so the lines AC and BD, they are perpendicular, right? So this means AC and BD perpendicular. So let's just write that in a sign. AC is perpendicular to BD. And so then our quadrilateral would be something like this, right? It would go like this, and that would be our four sides. It would be A, B, C, D, and then this would be P, right? That would be P, and the lengths would be 24, 32, 28, and 45, right? And so we want the perimeter of ABCD, and so to get the perimeter, since this is a right angle, we can just use the Pythagorean theorem on all of these right triangles, right? But then honestly, that's very time consuming. Here's a trick. We can just do these two, right? And so get AB. This is just 3 to 4, so that's easily 40. And AD, this is 24 and 45. That's equal to, if we divide by 3, that's going to be 8, and that's going to be 15. So this should be 17. So 17 times 3. So 17 times 3, which is 50, which is 51. AB is 40 and AD is 51, and we will be adding some more values from there, right? But then looking at the answer choices, first of all, we have integers, right? So we have to rule out these three, C or E. But then if C is true, if it's C, then we're going to have one value, one length. One length is going to be 2 times 48, that's 96, and these two are 91 already, so one length is going to be 5, right? But then that's not possible with either BC or CD, right? So C is not true, so C is also wrong, so the answer only remaining is B. If you also do BC and CD, if you get those two values, then you will find that it is indeed E. Our last problem, number 25. Let fx equals x squared plus 6x plus 1, and let R denote the set of points x, y in the coordinate plane such that this is true and this is also true. The area of R is closest to what we want, right? Okay, so there is a reason that I made this on a grid and not just like brought a grid in. And it's because just drawing a graph on here is simpler, right? And so first of all, let's try this condition. If fx plus fy is less than or equal to 0, and fx is x squared plus 6x plus 1, then let's just put that in there, x squared plus 6x plus 1, and then fy is just substituting x with y, right? So it's y squared plus 6y plus 1. But then this is going to be equal to a circle, right? Because this is just x plus 3 squared plus y plus 3 squared. This is less than or equal to 18 minus 2, which is 16, right? So this is going to be 16. And so if we have like a coordinate plane like this, and like this, then this will be like a circle centered on -3, -3, and it will have a radius of 4, right? And so if we make that circle will look like this, right? This will be that exact circle. And next up is this one. Yeah, next up is this one. Fx minus fy is less than or equal to 0. So for this, we would get x squared plus 6x plus 1 minus y squared plus 6y plus 1. This would be equal to x squared minus y squared plus 6x minus 6y, and this is less than or equal to 0. So if we take out x minus y times x plus y plus 6, this will be less than or equal to 0, right? So for this, there are two possible ways. So for this, we can have x minus y and x plus y plus 6. They can be positive and negative, or negative and positive, right? And so if it's positive and negative, then this would make it so that y, so y is greater than or equal to x, and y is greater than or equal to minus x, negative x minus 6, right? And if this is and if it's negative and positive, then it will be, the signs will be flipped. Y is less than or equal to x, and y is less than or equal to minus x minus 6, right? And so if we draw those two lines and then color those values, first of all, y is, for these two, we need a y equals x. So if we have a y equals x, then we will have that right there. This is y equals x. And for this one, we need a y equals negative x minus 6, right? So for that, we have this line right here. So this is y equals negative x minus 6, right? And our first one is y is greater than or equal to x. So from here this way, and y is greater than or equal to negative x minus 6. So it's this part, right? This part within the green circle. And for this, it's both are negative, so that means it's this part. And so what you can see is that it's half of the circle, right? And the circle has radius 4, so this is half times 4 squared pi, and this is 8 pi, right? So 8 pi is the area of R, and once it's closest to, and then we have integer values. So 8 pi, this is closest to 8 times 3.1 something something something. So this is 24.8 something something something. So this is closest to 25. So it's closest to 25. The answer is E. And so that was the problems in the AMC 12B from the year 2002. And thank you for watching.